Hello again, and welcome to another edition of Mr. Leong is on Teacher Training. So you get a YouTube video. So you should have this handout. Make sure Tara has given you a copy of this handout, 18B, constant rate of change, 18C, non-constant and average rates of change. The two main formulas we're going to be looking at is average speed is distance over time, and you'll be surprised how many people actually forget that it's going to be the total distance over the total time. It's important, just remember that that's how you calculate average speed. And very important for average rate of change, if you see an average rate of change question, it's just the change in the y all over the change in the x. Now, by change in the y, I'm talking about the vertical axis, and change in the x, I'm talking about your independent variables on the horizontal axis. So it might not always be x and y, it may be different variables, but we're talking about dependent over non-dependent, and it's just the change. So average rate of change, change in y on change in x. Let's look at this first example where we've got a car travels at a constant speed from Melbourne to Sydney. That distance is going to be 900 kilometers. It's going to take 500 minutes to find the speed. However, in kilometers per hour. We're pretty happy with our speed formula. So the speed, well, I need my answer in kilometers per hour, and I've got minutes. So what I like to do first is always convert my units at the beginning into what the answer requires. Kilometers is fine, but I need hours. So let's convert the minutes. So 500 minutes, and I know 480 minutes is 8 hours. So this would be 8 1/3 hours. That's what I would always do first. I always convert my units first, and then I can use the equation. So the average speed is the total distance. We've got 900 kilometers over the time. If I was doing this non-calculator, I'd probably do it like this. 8 1/3, that's going to be 25 over 3. So then the average speed is 2700 over 25. I mean, I definitely, if I'm doing non-calculator, I use improper. I use this divide type sign, so I can flip it. And then that's going to be 27. That's going to be 27 times 4, 108 kilometers per hour. For the distance time graph, it's all about labeling correctly. So label axes appropriately. So for distance, that's going to be over here, and it's going to be kilometers. And for time, which will be the independent variable as it commonly is, we're going to talk about hours. So over here, this is the time in hours, and we've said that it's a constant speed, so this is going to be direct proportion. So we're going to start at the origin, and we know it's going to be a straight line. We know that after the distance time graph, we know that after 500 minutes, it'll be 900 kilometers. I'm using hours here, so after 8 1/3 hours, which is going to be about here, it's going to be 900 minutes. And so it's all in the labeling. Label endpoints using coordinates. So after 8 1/3 hours, the distance is 900. Of course, we are going to use a ruler here. And so that's the important points. I can't stress enough the labeling. Label your axes correctly. It's not always going to be X and Y. Label your endpoints correctly with coordinates. Use a ruler. Let's have a look at example 2. Got a motorist. It's a funny looking car. A motorist travels 200 kilometers in 2.5 hours. So I've got the distance, I've got the time, stops for 1 hour, then travels a further 150 kilometers in 90 minutes. Find the average speed of the motorist over the 5 hours. So it's all in the wording, right? Over the 5 hours, I can see I've got 2.5, 1, and 1.5. That adds up to 5. So they're including the rest. Sometimes it will, sometimes it won't. It depends on what the question says. But here, for average speed, we're looking at total distance. So my total distance is the 200 and the 120. Total time is 5 hours, 64 kilometers per hour. Pretty straightforward. Let's look at this last example. Find the average rate of change of this function, it's a quadratic, as x changes from 1 to 4. Now I've graphed the function here, just so that we can get an idea of what's happening here. So as x changes from 1 to 4, what's the average rate of change? What we'll do is we're going to plot the points. So let's sub 1 into here. If I sub 1 into here, I get 2 take 3 plus 5. That's going to be 4. So this point here is 1, 4. And if I sub in 4, that's going to be 32, take 12, plus 5, that's going to be 25. So this point here is 4 and 25. Now, if I was to draw a segment here, we can see that the average rate of change is the change in y over the change in x. Now, y has gone from 4 to 25, so that change is 21, and x has gone from 1 to 4, so that change is 3. So the average rate of change here is 21 over 3, which is going to be 7. That's graphically, but let's say if we did it without using the graph and we were just looking at this question like so. What I would expect you to write is the average rate of change is, what we did is we subbed in 4 here to get 25. So this is f of x, so I'm going to sub in 4. We took away when we subbed in 1, and this is all over the change in x. So just as we had up here in our rules, on top is the change in y, on the bottom is the change in x. And if you were to use your calculator for this, I would say definitely define the function. So this is 2x squared, take 3x plus 5. Let's call this f of x. Once I've done that, I can just simply type in what I wrote here. So this is f of 4, take f of 1, all over 4 take 1, to get 7. This is accepted as working out because they've given me the function f of x. This was just to explain it and is not required. So that's it for the explanation of 18b and 18c. Please look at the questions from the layout for the rest of this double period, and have a good day.